Hello, welcome back. Today we're going to wrap up our study of phonology. So we're almost done studying the structure of sounds. The next step up is going to be the study of morphology, which is the structure of words. But before we leave phonology, I want to today focus on the variety of sound systems that we see across different languages of the world. This is a sort of fun and exciting lecture because now we're going to see some payoff for the hard work you've been doing over the last week or so in understanding phonology. So you've learned about phonemic analysis, you've learned the structure of how sound systems work. Now we're going to be able to apply that knowledge to start looking at the different languages of the world, describing those languages scientifically. You're going to get a sense of the incredible diversity that we see when we look at the different languages of the world, and also the striking similarities and commonalities we see in those systems of sounds. So here's phonology so far, the major points. Phonetics, remember, was all about just the mechanics of sounds. Phonology is about sound systems, how sound systems are constituted in languages. A phoneme is a single underlying sound category which can be expressed as multiple different phonetic variants, which are called allophones. Remember, phonemes represent sounds that are distinct for the purpose of distinguishing words. They are sounds whose distinctions are important for the meaning of what you're saying. If two sounds are contrastive, then that means that they must come from different phonemes, and the way you can tell that they're contrastive is that you can find a minimal pair. We talked about phonological rules. Phonological rules are a way of writing down, a way of scientifically describing how underlying phonemes translate into the actual phones that you hear and produce. And we saw that the 6 common kinds of phonological rules are assimilation, insertion, deletion, strengthening, weakening, metathesis. Assimilations when two neighboring sounds become similar to each other. Examples being stuff like nasal assimilation, voicing assimilation, and so on. Insertion is when a sound which is not present in the underlying phonemic form gets inserted into the surface phonetic form. Deletion is when an underlying sound is deleted. Strengthening is when a sound becomes more phonetically distinct, also called fortition, like aspiration. And weakening is when a sound becomes less phonetically distinct, which is also called lenition. Flapping, vowel reduction, final devoicing, etc. These are all examples of weakening. And metathesis, the last common kind of rule, that's when the order of two sounds is flipped. The order is flipped in metathesis. So those were the common kinds of recurring rules that you see across languages. Now what I want to talk about is what is the variety of sound systems we see across languages. We talked about the things that they often recur, the things they have in common. Now let's think about how do they differ? What are the axes along which languages differ in terms of their sound systems? We'll be asking questions like what phonemes exist in a language, and what are the constraints on how those phonemes go together in different languages. Now the first topic here is what's called phonemic inventories. That is the question of what sounds, what phonemic sounds exist in a language. So every language has what's called a phonemic inventory. That is a finite set of phonemes from which all words are built. Every language has both consonant and vowel phonemes. And so we're going to be looking now at what are the common patterns and the range of variation in consonant inventories and then in vowel inventories across languages. We'll start by looking at English. This is the English consonant inventory. This is the set of phonemes, consonant phonemes, which exist in English. Remember, these are phonemes, which means these are sounds which contrast with each other for the purposes of distinguishing words. So this table's not going to include things like aspirated versus unaspirated T, because that is not a contrastive difference. Those are not different phonemes. Those are just two different allophones of the same underlying phoneme T, which shows up as the T in this chart. So let's just take a look at the English phoneme inventory. Well, first thing we can note is that there's 24 of them. Basically, there are 24 different consonant phonemes in English. We're going to see that in terms of numbers, that's very typical. In terms of the number of consonant phonemes, English is a very typical language. 24 is just about average as far as these things go. I'd also like to take a look at the structure of the inventory. So when we look at how these things are arranged, it's not like just a random grab bag of sounds. Rather, there's something systematic. There's something systematic about this inventory. So, for example, let's just take a look at the obstruents. Remember, obstruents are consonants, which are stops or fricatives or affricates. So the obstruents are going to be things like the stops P and B and the fricatives F and V. Just taking a look at these, we notice that they come in pairs. In English, all of the obstruents come in pairs. There's a voiced version and an unvoiced version. So you have unvoiced P and you have voiced B. You have unvoiced S and you have voiced Z. They always come in these pairs. And in this table, those pairs are actually indicated using these terms fortis and lenis. You can just think of those as sort of fancier terms for voiced and unvoiced when it comes to phonemic inventories. The point is that the way that English generates these 24 different sounds is not by grabbing a bunch of random sounds from what's possible. Rather, we use a small set of features which all contrast with each other to form these different sounds. In this case, it's like we take each place of articulation that exists in English, and then we cross that with the two voicing states, voiced and unvoiced. And the result is that we get all these different consonants. This is the property of phoneme inventories, which we call systematicity. The consonant inventory is systematic. It uses a few contrasting features, in this case, a few different places of articulation, a few different manners of articulation, and just two voicing states. It uses that small set of features to create many phonemes. So that's the English consonant inventory. Now let's look at another language. This is the consonant inventory of phonemes for Mandarin Chinese. And you'll see when you look at this that it also has this systematic character. These sounds, in particular the obstruents, when you take a look at them, most of them come in pairs. In this case, though, the distinction of those pairs is not based on voicing. If you take a look at the chart, it's actually based on aspiration, not voicing. So you have in Mandarin not a contrast between voiced and unvoiced B and P, but rather a contrast between aspirated P and unaspirated P, which has the same effect of the English voicing contrast in terms of creating these pairs, but it's phonetically different. So in the pinyin writing system for Mandarin, the unaspirated stops here are actually spelled with a B. But you shouldn't be misled into thinking that that's actually a voice stop. That's just how it's spelled. Mandarin basically affects the same kind of distinction as English, except it does so using aspiration rather than voicing. Another thing I'd like to call your attention to here is that this is the inventory of phonemes, not the inventory of sounds. And so these are only the sounds which contrast each other in terms of distinguishing meanings. You might notice here that there are these things in parentheses. These are the alveolopalatal sounds like ch, j. Those sounds are actually not phonemes of the language. They're actually allophones of other phonemes, even though they're spelled distinctively. And they're such distinctive sounds that they make their way into this table in parentheses. But that's just to say that remember that when we talk about these inventories, we're talking about phonemes. And if you actually listen to someone speaking, you might hear a lot of sounds that you don't see in a table like this. Remember that those sounds would be allophones of the phonemes that are listed in this kind of table. So here's Mandarin. Mandarin is similar to English in terms of the size of its phoneme inventory, 19. It's also sort of in the average range. It has a bit fewer consonants than English, but it's still relatively average. Here's another language, Quechua. This is one of the major Native American languages which is still spoken in South America, especially in Peru and Bolivia. So Quechua has 28 different consonant phonemes, and again we see this systematic pattern. We see the systematicity, this sort of grid-like structure to the phoneme inventory. In particular, what we see here is not this two-way distinction of voicing, which is sort of multiplied across the different places of articulation. Rather, we actually have a three-way distinction here. So for each place of articulation, you have a stop in one of three different forms. It could be plain, which is an unaspirated, unvoiced stop, like ba. It could be aspirated, unvoiced, like pa. Or it could be ejective. Now remember, we talked about ejective consonants. That means that you're creating pressure using your glottis rather than your lungs. These are going to be sounds like pa. So every consonant, every stop rather, in Quechua comes in all these different places of articulation and in these three kinds of voicing. The result is a nice systematic structure that generates a lot of different sounds that can contrast with each other to distinguish words in this kind of language. Quechua, we see that this has more consonants than English. We're sort of moving up now in terms of the size of the inventory. So we've seen that consonant inventories are systematic. They use a few contrasting features to create very many different phonemes. For example, we saw that obstruents usually cross multiple places of articulation with multiple kinds of voicing. Things like voicing, aspiration, ejectivity, and so on. Language is typically, on average, like if you grab a random language, if you go to the library and go to the section where they have grammars of languages and you grab a random grammar, that language will probably usually have between 15 and 30 different consonant phonemes. That's sort of the size of the typical consonant phoneme inventory. But what I want to talk about now is the extremes. 15 to 30, that's like average, but let's think about how low it can go. How small can your consonant inventory get in a real human language? And then we're going to look at how big a consonant inventory can get in a real human language, and the answer is quite big. So here's a language with a small consonant inventory. This is Hawaiian. It has 8 different consonant phonemes. And just taking a look at this, we see that, again, it has this systematic structure. So we have a couple different places of articulation. We have both nasals and stops in those different places of articulation, and also sonorants. And we see some funny things. So remember, these are phonemes. These aren't sounds. If you actually listen to someone speaking Hawaiian, you will hear a lot of different sounds. You're going to hear some t sounds and some k sounds. But what this table shows is that the sounds t and k are actually just realizations of the same single underlying phoneme in Hawaiian, which is spelled with a K in the Hawaiian writing system. So in Hawaiian, we have a structure like this. The underlying phoneme k is expressed as the sounds t or k, depending on the context. And in fact, if you listen to someone speaking Hawaiian, you're going to hear a lot of other different consonant sounds. It turns out that the phoneme k can also be expressed as the sound d or the sound g in Hawaiian. Notice that there's no voicing alternation, there's no voicing contrast in the phonemes here. That means that in terms of the sounds, you could have whatever voicing you want, and it doesn't matter as far as distinguishing words. You'll even find the sound s as an allophone of the phoneme k in Hawaiian. So that's what a language with a small consonant inventory looks like. I'd like you to now ask yourself, is that as small as it can get? Can we have a language which has an even smaller consonant phoneme inventory, but which still functions as a language? Is this as small as it can get? Well, I'd like to show you another language. This is the language Rotokas, which is spoken on this small island to the north of Australia here. Rotokas is a language that has 6 phonemes in its consonant inventory. And we can see that these 6 phonemes are formed systematically, as usual, by the opposition of a voicing contrast, voiceless versus voice, with just 3 different places of articulation. So you have the sounds p to k, b to g, That's it for the consonants in this language. So this is a very small inventory, very systematic, very elegant in a way. But remember, these sounds, these are not the sounds you would hear. If you actually listen to someone speaking the language, you're going to hear a lot of different sounds. Those are allophonic variants of these underlying phonemes. In particular, in rotokas, that underlying phoneme d, the voiced alveolar stop, can be expressed as the sound d or the sound nasal n, or the sound lateral approximant l. So when you listen to this language, you will hear nasals, but those nasals are not phonemes. They're just allophonic variants of the voiced stops. So we've seen that typically languages have between 15 and 30 consonants in their inventory, and sort of the lower bound, the simplest you can get, is something like rotokas, a language that has 6 consonant phonemes, but bearing in mind that those phonemes have many different allophones. Now let's think about how big the inventory can get. Large consonant inventories. We'll start by looking at the Zulu language. This is a language which is spoken in the area indicated here in South Africa by about 9 million people. The Zulu language has 50 different consonant phonemes. And so remember, these are 50 different consonant sounds which all contrast with each other for distinguishing meanings. This means for every pair of consonant sounds in this table, you could find a minimal pair for that pair. We see, again, the systematic structure, except now instead of just a 2-way or a 3-way contrast in terms of your voicing, there's actually like a 5 or 6-way contrast in terms of whether each consonant is going to be plain or aspirated or slack voiced or implosive and so on. So we have only a few places of articulation crossed with very many different forms of voicing. We also see that this language has clicks. Remember, clicks are consonant phonemes which are formed by creating constriction at the velum or the uvula in your mouth to create sounds like. And there's very many different click phonemes in Zulu. These are actually borrowed from neighboring languages into the Zulu language. This is a large inventory. We see that this large inventory, just like the small inventories, results from the systematic contrast of just a few features that are crossed with each other. So, Zulu. How much bigger do you think a consonant inventory can get? This is the first example I'm showing you, so you know there's going to be something more complex, right? What could be more complex than Zulu? Let's take a look. We're going to talk about a language which was spoken in a very small region of the Caucasus in Asia and Europe. This is the Ubykh language, which was spoken in this small area on the Black Sea. So this is an extinct language. There are no remaining native speakers of this language. This is something that I haven't talked about yet in this class, but it's an extraordinarily important issue that's facing us today as a science of linguistics and also as a human species, the issue of language extinction. There is currently something like 6,000 different languages spoken in the world today, but many of them are only spoken by very small groups of people, and when those people pass away, the languages will go with them. So the Ubykh language no longer has native speakers. The last speaker of this language was this fellow named Tefik Assenj, who died in 1992. So when this fellow passed away, all the native knowledge of the language, all the stories, culture which were embedded in that language died with him. Language extinction is a true tragedy from a cultural and scientific standpoint. And the only reason that we can talk about the Ubykh language today is because before this fellow passed away, a group of linguists talked with him. They knew that he was the last speaker of this language. They conducted very many interviews with him, recorded the sounds he was producing, figured out the grammar of the language, wrote it down, analyzed the language very thoroughly. And so there are very good scientific descriptions, grammars, of the Ubykh language. This means that if there ever is a revitalization movement, if the Ubykh people decide they want to speak their native language again, they can draw on those resources in order to sort of revive their language in the way that many languages have been revived in this century and in the 20th century. So this is one of the key reasons why linguistics is important in the world today. Language documentation, documenting languages that are about to go extinct and which are of incalculable value to these communities. So we'll talk about the Ubich language and its consonant inventory. So here are the consonant phonemes in Ubich. It has 84 different consonant phonemes, again formed by this regular structure, the opposition of many different voicing forms, in this case with many different places of articulation, and also what's called secondary articulations. That means that when you produce a sound, it might be sort of deflected towards the palate, in which case we call it palatized. It might come with lip rounding, in which case we call it labialized. We cross our kinds of voicing with our secondary articulations, with our places of articulation, and the result is lots and lots of different consonant phonemes. So I encourage you to try to pronounce this. This is a word in Ubich, which means the one who had bought the cheese. So just try it out. Bearing in mind that the actual pronunciation in Ubich is going to be a bit different than this because there are phonological rules that need to be applied. So Ubich has 84 different consonants. Also, just think for yourself, how many vowels do you think this language has? How many different vowel phonemes do you think this language has? Well, the answer is 2. This is a language which has very, very many consonants and just 2 different vowels phonemically. So sort of all the information in this language is concentrated in the consonants. And if you would like to actually hear what it sounds like, you can follow this link here and hear Tefika Sench telling an interesting story in Ubich. You can hear what this enormously phonetically complex language actually sounds like. So, is this the upper bound on complexity of consonant phonemes? Do you think that there could be a more complex language in terms of just the number of consonant phonemes? Well, I'm asking the question, so yes, there is something more complex out there. So returning again to Southern Africa, but now not the Zulu language, we're going to look at this language, which is spoken by a small hunter-gatherer group called O. You'll notice that there is a click in the name of the language. So that's a little preview of what this language is going to be like. These are the non-click consonant phonemes of O, and we see that there's already a lot. It has the normal systematic structure. There's already a lot of these different phonemes without even yet considering the clicks, but the clicks are really where it really explodes in terms of the number of sounds. So in terms of clicks, we have a contrast involving 5 different variations of clicking depending on where exactly you're making the constriction in your mouth while you are doing the click, contrasted with very many different sort of manners of articulation for these clicks. So there's very, very many different gradations of clicks, distinctions like versus that kind of thing. All of these form contrastive pairs. Each of these is a full-fledged phoneme in this language. And this is typical for what are the so-called click languages. Languages which involve a lot of click sounds usually have lots and lots and lots of those click sounds. And that's because once you sort of get the idea of using these clicks in your language, it becomes easy to form these phonetic contrasts in terms of variations in how you form the click. So combining the click and the non-click consonants, we end up with a total of 164 consonant phonemes in the O language. And I'd like to actually just play a bit of this so you can hear what this sounds like, because it's really quite extraordinary. So for example, the name of the language in the language itself is some, I'm not going to try to pronounce it. The name of the language itself is given here phonemically, and you can see it has very many different clicks in it. It also has tone. Here is what it sounds like.
Chapter 1. 1 iyak abe 4. Tanaka chaka. Theophilus take kanseki makomna. Tukutari ku wanja ku kom taikena korikin.
So that's the O language. That is sort of the upper bound on how complex your consonant inventories can get. So you can have as many as 164 different consonants, and the very, very large consonant inventories typically come from the click languages, which are all concentrated in one language family in southern Africa. So that's the upper bound. We've seen now the lower bound in terms of simple consonant inventories, and we've seen the upper bound in terms of complex consonant inventories. Now let's turn to vowels. Remember, vowel inventories are represented as points in a vowel space because consonants are composed of discrete features. You're either voiced or you're not, whereas vowels are sort of formed from continuous features. A vowel in a language corresponds to a particular point in the continuous vowel space. So vowel inventories are going to be represented as points in that space. A very common kind of vowel inventory is the one which is represented by the Spanish language, which has sort of vowels at 5 different corners of the vowel space along the edges. The vowels are I, E, A, O, U. You see the same system of vowels in the Latin language. You see it in basically any language that has 5 vowels, usually has this particular set of 5 vowels. And it's an interesting question why, which we're going to explain. So in Spanish, you have 5 vowels. And typically in a language that has 5 vowels, they're arranged in a sort of shape like this. They sort of hug the edges of the vowel space. Another example of a 5-vowel language is Japanese. Now, remember, the actual exact points of these vowels in vowel space is a little bit different between Japanese and Spanish, but overall they look pretty similar, don't they? So in Japanese, the vowels are I, E, A, O, and U, which are not exactly the same as Spanish, but they're obviously pretty similar to the vowels in Spanish. So we see the same kind of pattern in these two languages, these two unrelated languages. When you have 5 vowels, then the shape looks exactly like, or looks approximately like this. So what's going on? Here's an example of a 7-vowel language, Italian. So Italian is like Spanish, except that it has more distinctions of height in terms of the mid-vowels. So in Italian, you have a distinction of E versus E, which is represented there by the letter E versus the letter epsilon, and also O versus O. This is a 7-vowel language, but clearly a similar structure to the 5-vowel language. Another kind of structure you often see is languages with 3 vowels. And when languages have 3 vowels, it's typically like this. The vowels are I, U, and A. This is the Arabic type pattern. You can also have languages with lots and lots of different vowels. For example, French has 15 different vowels scattered throughout the space. Not exactly scattered, there is sort of a pattern here. The vowels are still sort of hugging the edges of the vowel space, as you see. And remember, the Ubich language has only 2 vowel phonemes. Now remember, if you hear Ubich, you're going to hear a lot of different vowel sounds, but there's only phonemically 2 different vowel phonemes in Ubich, and these 2 vowel languages are not rare. In fact, they're quite common. And when you have 2 vowels, those vowels are almost always versus a distinction of height. Is high, a is low, relatively. So one thing to note is that just as we saw with consonants, there's a certain systematicity to the vowel inventories. In this case, it's systematicity with respect to vowel height and tongue position. So, for example, in Spanish and Japanese and Italian, you have a high front vowel and a high back vowel. You have a mid-front vowel and a mid-back vowel. You have this sort of grid-like systematicity. Vowel inventories are usually systematic in tongue height and tongue position. Now, are there any other patterns we saw in the vowel space? We saw that the vowels sort of hugged the edge of the vowel space. This is what we call the principle of maximal distinctiveness. Vowels are maximally distinctive, which means that within a language, they spread out to occupy extreme parts of the vowel space. The reason they do this is because that way they sound more different from each other. And so that way they're more useful for distinguishing words from each other within a language. So maximal distinctiveness makes it easier to hear distinctions among vowels. When you have a two-vowel system, then your principle of maximal distinctiveness usually shows up as a height contrast, contrasting a high with a low a. When you have three vowel systems, those vowels go into the corners, three corners of the vowel space. So you have a versus e versus u. When you have five vowels, you end up with the sort of Romance Spanish type system where you have a, I, U, E, O. Why? Because that satisfies the principle of maximal distinctiveness. So now we have talked about the variety of inventories of consonants and vowels across languages. And we're going to turn to the second major topic we're going to talk about, which is kinds of constraints on how sounds go together in languages. This is what's called phonotactics. And the phonotactics of a language is a lot of what gives each language its particular sound character. So what constraints do languages place on sequences of sounds and phonemes that go together to form words? Phonotactics means the study of the restrictions on sound combinations within a language. So what are English phonotactics like? Here's a question. What phonemes can appear at the beginning of a word in English? What sequences of phonemes can appear? For example, we know that eng, the velar nasal eng, as in king, is a phoneme in English, but it can't go at the beginning of a word. More specifically, it can't go in the onset of a syllable. So we don't have words like ngat in English. That's not a possible word of English. You wouldn't even know how to spell it, right? So it's not possible that English will acquire a word ngat because English speakers are not really going to be able to even pronounce it. English speakers would find that very hard to produce. Similarly, we have a phoneme zh in English, as in the word mirage, but you only get that phoneme zh at the beginning of a word if it is in a loanword from some other language. A loanword is a word that's borrowed from another language. So we see that English has a phonotactic constraint. You are not allowed to have a velar eng at the beginning of a word, and you are strongly discouraged from having the post-alveolar voiced fricative zh at the beginning of a word. So that is the restrictions on single consonants at beginnings of words and syllables. What about restrictions on consonant clusters? A consonant cluster is a sequence of consonants that are strung together with no vowels in between them. Like in the word street, you have s, t, a consonant cluster, three consonants glommed together with no vowels in between them. Here's some examples of consonant clusters at the beginnings of words in English. We have br as in bring, thur as in three, gl as in glean, fl as in fly, my as in music, hia as in humor, qu as in quick, swa as in sweet. So we see that, well, first of all, it is possible to have consonant clusters consisting of two consonants. And we also see that there's likely to be certain restrictions on what two consonants can go together. So I'm going to show you some more examples of consonant clusters. And I'd like you to think, are these consonant clusters attested in English? Can you find examples of words that start with these clusters in English? So fia, think about it. Can you think of something that starts with fia? Well, there's fury. So we do have this consonant cluster in English. How about blah? We do have plenty of words that start with blah, like blink. So yes, that is a licit consonant cluster in English. How about mla? Can you think of any words that start with mla? Probably not. And if you can't think of one, it's almost certainly a loanword from some foreign language, probably from a Slavic language. We don't really have words that start with mla in English. So English phonotactics excludes the possibility of an initial consonant cluster, M followed by L. How about thla? Can you think of any words that start with fla? Probably not. Again, this is not a valid consonant cluster in English phonotactics. How about shra? Shra. Well, you might think of shriek or shrill. So there are, in fact, words that start with a consonant cluster shra in English. How about this? Sra, sra. Are there English words with this consonant cluster? Now, this might vary depending on your own pronunciation. There is a country named Sri Lanka, but you'll find that many English speakers actually pronounce that as Sri Lanka. So English phonotactics doesn't really allow for a consonant cluster sra at the beginning of a word. And the result of that is that when we try to pronounce words in some other language which does allow that cluster, we sort of distort it until it sounds like something which is a licit cluster in English. So you have a word like Sri in Sri Lanka. For many English speakers, that's going to come out as Sri Lanka. We're sort of melding the word to English phonotactics. Now, let's look at some more examples. Stra. Can you think of a word that starts with stra? Well, we talked about street. So there's plenty of words in English that start with a sequence of 3 consonants. And this is actually something which is somewhat rare across languages. 3 consonants in a consonant cluster counts as complex. This is something which is hard for people to pronounce if they're coming to English from a second language. Stra, 3 consonants together in street, so English does allow clusters of 3 consonants. How about 4? Can you think of any words that start with spra? Certainly not. And if you asked an English speaker to pronounce a word, maybe from some other language that starts with spra, the English speaker is probably going to insert a vowel in there in order to make it even pronounceable. They're probably going to make it stpra or something in order to make the word conform to what they're used to pronouncing, which is English phonotactics. How about stfra? No, we don't have this in English. So we see that English has a constraint that you're only allowed to have 3 consonants in a consonant cluster. You're not allowed to have 4 consonants in a consonant cluster, at least in syllable onsets. This is a phonotactic constraint of English. And we can summarize this kind of syllable, a syllable which has 3 consonants in a cluster at the beginning, followed by a vowel or a syllabic consonant. We can summarize that with a notation that looks like this. CCCV, that refers to the class of syllables which consist of 3 consonants strung together followed by 1 vowel. So we can apply this kind of template to understand the variety of possible syllables in English. We see that English allows syllables of the form V, just a plain vowel, as in the word We see that it allows things like CCV, CCC, as in a word like crafts. We see that it allows CCC v CCC, the most complex possible syllable in English, in a word like strengths. So English phonotactics is actually pretty complex in terms of the consonant clusters it allows. English allows 3 consonants in a row in syllable onsets and in syllable codas. There are languages that allow more, and there's languages that allow less. So for example, in the Hawaiian language, remember this language which only had 8 different consonant phonemes, the only valid syllables in the Hawaiian language are CV and V. So a word like strengths is not something that could exist in the Hawaiian language. Every consonant in that consonant cluster would have to be broken up by inserting a vowel. So it would have to come out as something like sa, ta, ra, na, nga, tha, sa. Something like that would be the closest approximation to the English word strengths in the Hawaiian language. A language like Indonesian is a little more complex than Hawaiian, but still not as complex as English. It allows syllables of the form CV, V, VC, and CVC. It doesn't allow 2 consonants at the beginning of a word. So a word like stop would not be something that could exist in the Indonesian language. And then Hebrew is a language which is still more complex, although not yet as complex as English in terms of its syllable structure, allowing 2 consonants before or after the vowel in a syllable. So I've been talking about what happens when you try to pronounce one word from another language in some other language. So what happens when you try to adapt a loan word into your language, but that loan word doesn't fit the phonotactics of your language? What happens? So there's basically two ways that loan words are sort of altered phonemically or phonetically in order to fit the phonotactics of the target language. Option one is that you just delete the troublesome phonemes. So we had this in English. So in Greek, there was this word, pterodactyl, which meant like wing finger, but it was later used in English to refer to a kind of dinosaur. And when this word was adapted from Greek into English, there was a problem because the Greek word starts with a consonant cluster pt, which is not allowed in English. English does not allow consonant clusters like pt with two stops at a beginning of a syllable. And so the way that this was projected into English was that we basically just dropped the p sound and we got pterodactyl instead of pterodactyl. So one solution which languages adopt when they're adapting these loanwords is to just drop the troublesome phonemes until you end up with something that matches the phonotactics of your language. The other option is to insert vowels in order to break up the troublesome consonant clusters. This is a process called epenthesis. And you see this in examples like, in this case, we have a Polish word coming into English. The Polish word Gdansk, which is the name of a city, starts with a consonant cluster gd, which doesn't exist in English phonotactics. And so the way that that ends up being projected into English is by adding a schwa vowel between the g and the d to get Gdansk. Gdansk. Another example would be like if you take the English word plastic, which as you see here has a really pretty complex syllable structure, and then send that into a language like Japanese, which has strong restrictions, which only allows for very simple consonant vowel type syllables. When you project this word into Japanese, plastic, what you're going to get out is something like purasutiku. So a bunch of vowels are inserted in order to break up those consonant clusters and make it conform to Japanese phonotactics. Japanese, in fact, only allows syllables of the form consonant vowel or consonant vowel followed by a nasal. And so you have to add a lot of epenthetic vowels in order to adapt a word into Japanese. So we've seen that languages differ in their phonemic inventories. We've seen that phonemic inventories are systematic. So they use a small set of features combined with each other to create a larger set of phonemes. Consonant inventories range from as small as 6 to as large as 164 different phonemes. Vowel inventories are what's called maximally distinct, which means the vowels are sort of repelled from each other in vowel space so that they sound distinct from each other. We've seen that languages have phonotactic constraints on what phonemes can go together in syllables. Some allow for these complex consonant clusters, like English, and other languages don't. And loanwords are adapted to native phonotactics either by deleting or inserting phonemes until you get something which fits the native language phonotactics. So that's it for phonology. I'd like to wrap up by giving you some pointers towards where you might see phonology in your future and future classes you might want to take here about phonology. So phonology classes at UCI include these. We have a whole class about phonology. We also have advanced offerings in phonology. You would be studying things like the structure of phonological rules across the languages of the world. Phonemic analysis and phonology more generally is typically the first step you take in language documentation. So remember that case of that fellow Tevfik Assange who was the last speaker of Ubich. When linguists started talking to him and they wanted to document his language, the first thing they had to figure out was the phonology. So they tried to elicit minimal pairs and figure out what are the phonemes, what are the allophones. Phonology is also critical for speech therapy. One of the big issues that can happen in terms of speech disorders is that people are unaware of phonemic distinctions. So maybe they're not really aware of the distinction between a p and a b sound in English. And one way you can help them is to drill them using minimal pairs in order to train them to really hear these distinctions. It's also important for how you actually describe the pathologies people are experiencing. Teaching phonemic awareness involves these sort of minimal pairs. And you can actually get these nice flashcards with examples of minimal pairs, in this case for English, for fronting and backing. Now you know what that means. That refers to a particular vowel distinction in English.